So, very good evening to one and all. Thank you for joining. So, very good evening to all the participants who have joined the 30-day masterclass on advanced VLSI design and verification. So, very good evening to one and all. Thank you for your joining. So, Valarmadi, very good evening. Valarmadi from Milupuram. Thank you for your information. Thank you for your response. Very good evening, Venkat. Very good evening. So Subhastri, so yeah, we will try to upload as soon as possible. Okay, don't worry about that. So we are trying to upload as soon as possible. So and then Hemant Chandra Naidu, very good evening. So Nikesh Tota, very good evening. Rishi Krishna, very good evening. Thank you for your joining. So thank you for your presence in this 30-day masterclass on advanced VLSI design and verification. So Hemanathan Sampat, very good evening. So today we are gonna see some Enum and then Enum data types and then Enum methods, and then we'll see the array, unpacked array, packed array, and then we'll see introduction about class, oops concept, and also we'll try to write some code for 4-bit adder. So till now I didn't write any code for a design circuit, so I will try to write 4-bit adder. Okay, so initially we will see the 4-bit adder and then we will start the Enum. Okay, so yesterday we seen data types and then data types description, how many set it having. So and then we seen some SystemVerilog features like a coverages, oops concept. Okay, today we are gonna see Enum. So good evening to one and all. Thank you for your joining. So directly I'm going to write some Verilog code for SystemVerilog code to write 4-bit adder. So and then please try to install the Costas mental graphics Costas as soon as possible. Then only you can try in the tool. So in the 6th day after the 11th or 10th, after the 10 days, 10th day of our masterclass, we will start work with the Costas tool. So from up to 10 days you have time, so use that to try to install the Intel Cortex Intel mental graphics. So and then I'm going to use Video Playground. So I'm just writing the 4-bit adder. So, okay, I'm going to write a 4-bit adder. 4-bit adder means, so I'm just showing how to write the design code by using the behavioral model. Okay, this is a behavioral model style, writing the code, design code. Okay, I'm going to write 4-bit adder. It means it will count from 0 to 15. 4-bit means 15. So and then I'm using it is a behavioral model style. Okay, this is the behavior model style. So and then I'm going to write the SystemVerilog code. So very good evening to one and all. Thank you for joining. So I'm directly going to write some 4-bit adder code. Then only you can understand how to write a design code. So this is a very simple 4-bit adder. So just I'm going to write here. So module, my module name is 4-bit. And one more thing, while writing the module name, you can't write 4 or any numbers starting name of like a starting character of your module name. Why? Because of you have to use always character while writing the module name. You can't use 4. It means it will throw an error. So you have to use always character as the first character as your module name. So counter. So if I write here 4 means, I will get an error. So you have to always write, you have to always start with the character while writing the module name. So and then so this is my module name, counter is, and then so I have to design the 4-bit adder means. So it will do calculations, it will do incrementation. Incrementation means it will start from 0 and then it will count up to 15. So it will start from 0. So we have to use some event triggering. So I'm going to use sequential logic for that. Sequential logic means nothing but I'm going to use clock. Okay, so my input is uh, clock and reset. This is my input, and then my outputs are D out, data out, or counter out. So this is my input and output signals of my 4-bit counter. Okay, so this is my module, this is my counter, this is my module, this is my input and output signals. I'm going to use always block, always at passage of clock. It means if this is one always block, we already know that in the Verilog we are having this is my always block. Okay, this always block, when it will work means if the passage, this always clock always looking for passage of clock. So this clock is my input. If any occurrence of passage means it will do execute this always block. Okay, so if it is passage occurs means it will execute, and then it will check always only the passage of clock. So this always block fully based on the passages. Each and every transition, each and every assignments are based on the passages only. Okay, so this is my always block. So I'm writing some reset condition. If my reset signal is high means 1-bit binary 1, it means begin end. If my reset signal is high means I'm saying D out will be 0, 4-bit of binary 0. Okay, so I'm just assigning. So my logic is, if my counter is in the reset condition, reset state means my output will be 0 only. This is my rule, this is my first condition. So I just return this by using if logic. Okay, so and then end, else begin end. I'm just saying if my counter is not in reset condition means I will get an increment operator, which means it will do counting. Okay, so D out will be, so this is a non-blocking assignments. So there are 2 assignments. This means this one equal symbol is refers to blocking assignments. And then this less than or equal symbol is refers to non-blocking assignments. So before going to that, I want to ask one thing. How many people are aware of the blocking assignment, non-blocking assignments? Can anyone respond in chat box? How many people are aware of the non-blocking and the blocking assignments in Verilog? So it is very important also. So how many people are knowing the non-blocking and blocking assignments in Verilog? Can anyone respond in chat box? So very good evening to Bharata Singh, Tarun, Vasu, Narayana Murthy. So very good evening, thank you for joining. Radhika Kumar, and then Pranav, and then Amurtha. So very good evening. So Lakshmi, very good evening. So Naga Srinivasara, very good evening. So thank you for your response. So and then I want to know that thing. So how many people are aware of or are any idea about non-blocking and blocking assignments in Verilog? How many people are know blocking assignment and non-blocking assignments? So Radhakrishna, hi. So just tell me that only. So how many people are know the blocking assignment, non-blocking assignments in Verilog? So because of it is there is some lot of difference between blocking assignment and then non-blocking assignments. So this is a blocking assignments. One equal symbol is known as blocking assignments, and then this less than or equal symbol is known as non-blocking assignments. Okay. So Naranamurthy, yes, thank you. So it's good. So sir, my daily session video uploaded lately, so only 2 sessions video are there. So we'll try to upload as soon as possible. So we have to do some editing work, so then only we can upload. So we'll upload it as soon as possible. So I'll try to my coordinator, so they will upload it as soon as possible. So and then yeah, some people are know the blocking and non-blocking assignments. The main difference is there is a one timing regions in Verilog. So timing regions is nothing but so each and every code, while we are writing Verilog code, SystemVerilog code, each and every line having some timing regions. So it will execute based on the timing regions only. So if I time means I will explain the today itself. Okay. So yeah, it is a continuous assignment statement, I think. No. So this is you are just this less than or equal to symbol is known as non-blocking. So this is only blocking assignments only is the continuous assignments. So blocking assignment is now also known as continuous assignments, and then this is known as non-blocking assignments. So I will tell you difference at the end of the sessions. So just I will try to finish that code. Okay. So I'm going to use non-blocking assignments, so it will execute in the NBA region. So there are several regions in Verilog and SystemVerilog. So in the next tomorrow or today I will explain the regions also. So and then so I want to increment. So 4-bit binary 00 plus 1, 1-bit binary 1. So you can see here I'm just incrementing, I'm just adding to 1. So initially having 0 and then I'm just adding to 1. It means at every passage of clock it will do increment. From it will start from 0 and then it will stop up to 15. Okay. So this is a very simple design code. Okay. Here I'm going to write test bench for this. Okay. I'm going to write test bench for this. So I'm going to write test bench here. So I'm just write fastly module tb. So we are writing the SystemVerilog code. Okay. So previously while writing the Verilog, output signal must be in the void data type, input signal must be in the rich data type. But here we can use logic data type. Logic. Okay. Logic clock reset. RST means reset, and then logic dout. So name must be in the same, then only you won't confuse. D out. So this is my internal signals of my test bench, and then I want to do instantiation. So I'm just connecting my design code. My module name is design code module name is counter. I just copy and paste here, and then I will write the instance name. So I'm going to use one shortcut method, dot star. It is refers to if you are dealing with less number of signals, like a 3 to 5 means it will automatically connect. So we won't try to each and every pin connect, like a dot clock and inside the bracket clock. So this is a formal method, this is a good method, but you can also use some trick. This is one kind of trick, easy method. So do while doing the instantiation. Okay. So and then I'm just it means it will automatically connect this clock and then this clock. It will automatically connect the test pin signals and also design code signals. Okay, this is a method of instantiation. It will do automatically if you are following this method. Dot star means it will automatically connect. So and then inside my initial begin. So this is my simulation time. So before going to that, I want to create clock. Clock is nothing but, so we know that clock is zeros and ones. Combination of 0 and on time and off time is known as one kind of clock cycle. Okay. So I'm going to create a clock. So I'm using always keyword, always at every 5 nanoseconds my clock will be toggling. It means at every 5 nanoseconds it clock will be toggle. So how it will toggle means I will show you. So before in the starting stage of stimulus, reset equal to high and then clock equal to low. So clock, I'm just assigning, I'm just passing stimulus for my design code. Okay, at the starting stage of simulation, my counter will be in the reset condition, and then the clock signal having 0. So the clock here, the clock will having 0, and then here also clock will having 0. But here you can see here bitwise not, I'm using a bitwise not, so it will change into 1, and then that 1 will assign to the this clock, and then again this clock having 1. So this will and then here also we can say that it having 1, and then not of 1 is 0, and then it will do the toggling, it will changing from 0 to 0 to 1, 0 to 1. Okay, see that's by using this method we can create the clock, and then there are two types of methods, there are several methods to create the clock. Okay, this is one of the method by using the always keyword. So and then after the one clock cycle means 10 nanoseconds, I will give and then after 10 nanosecond, okay, so after 10 nanoseconds it will do incrementing, it means reset. I just off my reset. So after 10 nanosecond I just off my reset, then only my counter will be working, it will do counting. So I'm just counting up to 100 or 200 nanoseconds. Okay, 200 nanoseconds. After that I will finish my simulation by using the dollar finish. It will finish the simulation. Okay, it will finish the simulation. So and then I will write some dollar monitor to display my output. So I want to display my time. Okay, time equal to percentage model of t, and then data out equal to, I want to see in my decimal, only I can easily understand. So and then dollar time, it will display the dollar, I'm using dollar time here, it means it will display the simulation timing. So and then d out. Okay, so and then in module, so I just run this. So I am writing this code means it is a very simple way of writing counter, that's what I'm showing. So please try to write the full adder, half adder, mux, demux code by your own using SystemVerilog language. So it is continuous assignment statement, I think. No, thank you Nakash. So thank you for response. So Arshit M, very good evening. So here I want to change like a 4-bit of binary ones, 4-bit of binary one. Or else I can easily change, if you're confusing means you can use this symbol. Already we having the 4 tick, binary 0 0 0 plus 1. So why I am getting wrong means here I want to give the range. So 4-bit means 3 down to 0, and also here also I want to change 3 down to 0. So I just made mistake here. So why here we can see here reg is a single bit data type, but I am dealing with 4-bit means, so I want to give the range vector. So this may, and then this is why we have to aware of the data types. Why? Because of we already we have to know the data types, and only we can easily understand the Verilog code. And you can see here my reset on the time of 10th nanoseconds, my reset. So I will just display my reset also. I want to see reset in the I want to see the output in reset in the binary, and then so and then I add here reset. After the 300 nanosecond, I want to finish $finish FINISH. Four bit of binary 1. Why it's showing two outputs only? So just a minute. It will count from 0 to 1, but it will don't count 2, 3, 4 also. Let me check that. Or else I can use d underscore out 4 bit of 1, or else 1. We can use this also. We so you can see here. So here you have to give like a d out equal to d out plus 1. So it will do counting from 0 to 15, and also you can see the output here. It will continuously counting from 0, 1, 2, 3, 4, 5, 15 up to 15. It won't count more than 15. Why? Because of my bit range is 3 down to 0 only. Okay, so it won't count more than 15. So why? Because of the range of bit is 4 bit only. So by using 4 bit we can count up to 15, so we can't count more than 15. So that's why it will automatically move to 0. Why? Because of I am running the simulation up to 300 nanoseconds, so it will stop at the 300 nanoseconds. You can see here, and it will, after the 305 nanosecond, it will stop the simulation. The simulation will be stopped. So this is how writing the design code. Main thing is you have to follow this d out equal to d out plus 1. Okay, so and then I here I made mistake here and then I corrected. So till now, do you guys have any doubt, if you just ask me. So and then we'll move to the enum. So this is how writing the counter code in very SystemVerilog. So good evening MPSS Ganga Devi. So we will get the attendance link. So and then enum. So enum is kind of like a parameter only. So yesterday I also said no. So enum is type of set of named values. The simplest enum type declaration contains list of constant names and also one or more variables. So I'm going to write just code for enum. So I'm going to write enum code, then only you can easily understand. Module, my module name is enum type. So enum, it having lot of methods. So main thing is, you can see here, this is my syntax of enum. This is a enum keyword, and then inside the bracket we can save the, we can store the values, like we can store the constants or any named constants. So and then this is my enum name. Each and every elements inside the enum having some values. It will start from 0, then it will automatically increasing 0 1 2 3 4 5. So it will assign the values by default. Okay, and then we can also override the values. How means we can assign if you can see here, this is a red is one element of enum. I am assigning value as a red equal to 0. It means the first element of enum having the 0 value. So green having the 1, and then blue having the 4. Here yellow must have the value of 5. Okay, so it will do increment. So it will do increment count. Okay, it won't decrement. And then here white is 10 means black is 11. So here say we 5 having the, sorry, yellow having the 5 value, but so I am assigned 10 value for my white. So we can overwrite, and then we can make like this also. So if you follow this method, it won't throw an error. But here I assigned 5 value, so 5 value for my blue element of enum. But if I assigned 3 value for this yellow, means it will throw an error. So you can't give the less than 4 value for the remaining enum elements. Okay, so I will just write the code for the enum. So to explain this, so enum types. So and then try to don't you have to don't use the data type as a model name. It will throw an error. Okay, and then end module. This is my syntax. So I just create my own enum. This is enum syntax. So enum, this is my enum keyword, and then enum elements. Inside the flower packet, I am writing the enum elements: red, green, flower, sorry, red, green, blue, pink, orange. So these are my enum elements. Okay, and then this is my enum name, color. So by default, these each and every elements having values. Red having 0, it will start from 0 1 2 3 4 5. So by default it having the values. So I am going to print the default values of enum. How we can print means by using this. So by using this enum name, we can display this, we can access these enum elements. Okay, by how we can do means I will show you. Okay, so and then colors, color equal to, so I'm going to use, so you can, so by using though, and then these are the main methods in enum. So you have to know also. So enum first is this enum method. First means it will display the, it will return the value of the first element. Okay, last means it will display the value of the last element in enum. So next means it will returns the value of next number of enumeration. So and then next n means it will returns the value of the nth number of enum. So and then previous means whatever the current element of enum means, it will display the previous enum element value. And then So num is returns a number of elements in the enum, okay, and then name, so it is returns a string representation. So name means it will display the enum name. So here these are the enum elements, red, green, blue, and then if you are using the name means it will display the enum element name, okay. This is how we have to create, okay. So and then I will show you the $display. I want to display the color. I want to display the value of values of first my first enum. Color dot first. So it means it will display color dot means by using this color enum name I can access the enum elements. So if I did means let's see what is the output. So I didn't write any input output ports. Why? Because of I am doing simulation only. So SystemVerilog enum are only for we can also use in design code, but we can also use in test bench. So I'm going to do only test bench like a design verification only. That's why I didn't write any input output signals. You can see here 0. I received 0 output. Why? Because of I already said no enum having the default value of 0. Is red having 0, green having 1, blue having 2. So if I can assign the also value. I can also assign the value for enum elements. If I assign 5 means, let's see what will happen. You can see here this is the 5. You can see I received 5 here. Why? Because of the enum value. So enum value of red is 5. So and then so I can use also another methods of enum. Next last, well, we will see the last method. Last, it will print the last enum element value, okay. These are the enum methods. So 9, why it displays 9 means, so I am assigned 5 here, red equal to 5, so red element having 5, so green 6. So it will always incrementing based on the previous enum element value. So it won't decrement, it won't just mixed values, it will always increment, okay. 5 means it will green having 6, blue having 7, pink having 8, orange having 9. So that's why like this enum will works, okay. So till now, do you guys any doubt from enum? So doubt, danger, can you ask your doubt? So by using this, if you have any doubt in enum, just ask it. So these are the enum methods. So it's very important. It's not all that much important, but you have to know. So what are the enum methods? So do you guys any doubt till now? You can ask now. So and then so this is very simple. So you can try it yourself. So and then I will move into arrays. So arrays in the packed array. So you can also see here I created one enum, good and bad. So it good having 0, bad having 1. So okay, no doubt. So I will move to the arrays. So in the Verilog also we see in the arrays fixed array to single dimensional array. So this is a multi-dimensional array. So array is a collection of variables, all the same data type, all same type, access using the same name plus and one or more indices. So that's the main thing is arrays. We can create the memory locations. So this is a fixed array. Fixed array means that array syntax we know that we have to write data type and then array name and array range. So here 6. Can you explain the once again code? So enum code, okay. So enum. So enum means enum. By using the enum, we can assign the values for the enum elements, okay. For example, if you know the parameter, okay. For parameter, yesterday we seen the parameter. Parameter means parameter name. So if you assign the value for the parameter name means if you are using that particular parameter name wherever while in the code, it will automatically update. For example, parameter having one name, parameter name, so that name we can assign the value. For that name we can assign the value, okay, like a 5 6 anything, we can assign the value for the parameter name. Okay, if you are using the parameter name as your in your code means that value on that time, so it will automatically assign the value. Okay, whatever written the value for the parameter, it will automatically assign, it will do automatically assigning the value for the signal. Okay, for example, enum one kind of features in SystemVerilog. So this is enum syntax, enum, this is enum name. Okay, inside the flavor bucket we can create the value names or elements of enum. These are called, these things are called as enum elements. Okay, red, green, blue, pink are enum elements. Each and every enum elements having some elements. By default it having some values. It will start from the 0. So first element having 0, next element having 1, and the next element having 2, next element having 3. So here, and also we can assign the values for the enum elements. But while assigning the values for enum element means it must be in the increasing order. So if I'm here, you can see here I'm assigning the value for enum element of red is 5. So the green having 6, blue having 7. So it will assign the value increment order based on the previous enum elements. Okay, so this is how enum will works. So if I assigned here green equal to 4 means I will get an error. So why? Because of it is not an enum function. So enum always do incrementing operation. So you can see here red equal to 5, green equal to 4. So I will get an error. Why? Because of, you can see the error in the transcript. Enum, so enum member blue does not have a unique value. Why? Because of unique value means it will be in the more than previous value. So 4 means red having 4, so red having 5. So green must be in the 6 or 7. More than 5 only we have to assign for green. So we can't assign the 5 and then less than 5 for remaining these enum values. So that's why you will get an error. That error name is enum member blue does not have a unique value. Okay, if I assigned here 6 means I didn't get an error. So enum is user defined data type, can be accessed by indexes a number every time in the program. Yeah, you can, Naga Srinivasa, you telling correctly. So and then now I didn't get an error. You can see here I didn't get an error. So it will display the last value of the enum member. Okay, this is how enum works. So and then we'll see the arrays. So we know that arrays, we have the fixed, this is the fixed array, this is a unpacked multi-dimensional array, so rows and columns. So and then this is unpacked array. So in the SystemVerilog we having the two types of arrays, static arrays. Okay, but the another types are packed array and unpacked array. So you can see here, this is how, if you follow this method, byte, this is my array name 10. So it means it having 10 memory locations, 10 indexes. Okay, this is how look like while created this type of array, static array. So this is a multi-dimensional array. So you can see here, so this first first vector 2 down to 0 is refers to row, and then 3 down to 0 refers to columns. So each and every row having the 4 columns. It means each and every row we can store the four values of integer type. Okay, so this is how look like. So coming to the packed and unpacked array means the term packed array is refers to dimension declared before the data type. So this means you can see here, this is one array declaration. Bit is a data type, 7 down to 0 is my array range, and then temp underscore variable, this is my array name. So I declared, I mentioned array range dimension before the array name. So this is, if I follow this method, means it is a packed array type. Okay, and then if I given then range after the array name, means this is an unpacked array. Okay, this is unpacked array declaration. So if I give the name after the range, means array name, if I give the array name after the range, means is known as packed array. And then if I give the array name of before the array range, so before the dimension of array, if I give the array name, means this is an unpacked array. Okay, this is how it works. So this is how basic definition of array, packed array and unpacked array. Basically, packed array are in the contiguous in nature. So okay, contiguous is nothing but it will create the memory location. It will create the memory location next to next. Okay, I will show the what is contiguous and what is non-contiguous. So packed array can be a single bit data type, so rich logic bit. So enumerator types and recursive packed arrays are packed arrays and packed structures. So enum also one kind of packed arrays. So on one dimension packed arrays is referred as a vectors. So and then I will show you the what is a contiguous. So packed arrays are in the contiguous nature. So contiguous is nothing but, you can see here, this is my array range, like array dimensions, but I declared array name after the my dimension. So this is comes under the packed array. So packed array is a contiguous contiguous in nature. So contiguous is nothing but it will make the memory location next to the row. So next to the one row of memory location. It means, so for example, if you take this, means, so here 2 down to 0, it means this particular array of 5 having the 3 rows, and then each and every row it having the 7 columns. 3 rows, 7 columns, each and every row having the 7 columns. But it will create the memory look like this. Okay, it will create the memory, it will create the rows very next to the memory, very next to the previous array. So this is my previous array of 0, array of 1, array of 2. So it will create the array very next to the previous array. So you can see here, this is my array is 0. So why? Because of we have in the 3 rows, so means 3 memory locations. Okay, this is my first memory location, this is my second memory location, this is my third memory location. So in the first memory location I can store 7 bit of data. So this is my first array, it can store 7 bit of data. So you can see here 0 to 7, sorry 8, 7 down to 0 means 8 memory location. So here also 0 to 7, 0 to 7. So but the memory creation of this unpacked array is contiguous. So it will create the memory location very next to the array, previous array. Next to the previous array means, so here it is refers to the 3 arrays, 3 memory locations. So by generally we can say that it will create the memory location very next to the previous memory location. Okay, this is how it works. So and then unpacked arrays can also any data. So packed array must be in the single bit. Okay, packed arrays must be in the single bit data type, but unpacked array we can make as any data type. So unpacked arrays shall be declared by specifying the element range after the array. We know that we unpacked array is nothing but we can give the name before the dimension of array. Okay, so unpacked array may or may not be so represented as a contiguous set of it. So it may be, so unpacked array is not, it's not, it may be in the contiguous in nature, or it may be in the non-contiguous in nature. So this is example for unpacked array. This is refers to after the array name is refers to the array locations, array rows. Okay, 3 rows, each and every rows having the 8 bit of data, so 8 bit of columns. So this is how looks like. So this is how unpacked array memory created. So each and every memory location created separated, not linked. Okay, it is very separated of unpacked array. So and then, so I already said no, we having the timing regions in SystemVerilog. So these are the regions: preponed region, active region, inactive region, NBA region, observed region, reactive region, postponed region. So we'll see one by one in the upcoming days. Why? Because of it will more confusing. So while using the code we can easily understand this. So firstly we have to know the Verilog timing region, then we will move into SystemVerilog timing regions. In Verilog we having only 4 timing regions, but here in SystemVerilog we having the more than 4. We having the up to 17 timing regions. Okay, like a postpone, prepone, and then pre-active, and then post inactive, and then pre-inactive, post inactive, pre NBA, post NBA, like that. We having the number of regions SystemVerilog. Okay, timing regions. So we'll see that this topic in the upcoming days. I think till now you guys are getting packet array and unpacked array. Main thing is packet array is a single bit array, so we can only by using the if you are using the packet array means you can use only the single bit arrays, single bit data types, and then it is in contiguous in nature. So contiguous is nothing but it will create the memory location very next to the previous one, and then unpacked array is it is a non-contiguous. It may be non-contiguous or contiguous, and then it is you can use any data type for creating unpacked array. Okay, so if you are writing the array name after the dimension of array, is uh, packed array. If you are writing the name before the dimension of array is known as unpacked array. Okay, this is how we can create the packed array and unpacked array. So, and then till now you guys are getting, I think so. So do you guys any doubt you can ask now. Enum is user, so Enum also completed. So, and then if you guys are really interested in this master class, you can convert into 1 month of internship on advanced VLSI design and verification. So you will get the benefits of this that is recording sessions. You can access up to 180 days, and then you will get all the PPTs, and then you can also download, and then you will get the 4+ exclusive projects, and then you will get the IETE confirmation letter, and then you will get the academic internship report, and then we are providing weekly sessions, and then we will give the task every day. So every day and then weekly basis, and then you will get the high valued IETE internship certificate. So these are the benefits you will get at the discounted fee of just 999. By using this link you will get, and then you can also get this link in the chat box. So by our regular fee is 4999. So in this masterclass period we are providing us a discounted fee of just 999. This is a limited time period offer, please avail it. So, and then after clicking the registration link you will see this window. Here in this domain you have to choose advanced VLSI design and verification. Okay, then only you will get our internship program. So, and then you will get this certificate after the internship program. This is a sample certificate you will get at end of the internship program. So you will get from the IETE, Institution of Electronics and Telecommunication Engineering. It's like a central government institution. So this is the way of getting internship program. You can use this link to get the internship program. So, and then we'll move to the SystemVerilog task and function. So before going to that, I want to know how many people are aware of the task and functions. So task and function, this is it is kind of one module, one block, or we have in SystemVerilog, and also we have in the Verilog. Tasks are used in the all programming languages, generally known as procedures or subordinates. These lines of code are enclosed in task and in task. So, and then it include the main body of code. They can called many times reducing code. So it's like a class itself. So we can create the one task. It will start from task name, and then end task. Inside the task and end task we can write the logic. So, and then if you want that logic means you can just call the task, you can just implement in your code. Okay, this is how we can create the task. Function also like that only. So there are a lot of difference between task and function. So function same like the task, it having function name and end function. Inside the function we can write the logic. The main difference between the task and function is inside the task we can give the delay, and then inside the task port list we can give the input and output signal for the task module. but in the function we can give only the input signals only we can create in the function port list, and also inside the function you can't give the delay. So and then inside the task you can call the function, but inside the function you can't you can't uh, you can't call the task. Okay, inside the task you can call the function, but inside the function you can't call the task. So and then usage of the function is very synthesizable. So while writing the design code you can use the function, but task is non-synthesizable. It is only using for test bench. Okay, so and then argument passing. So task having only the function having only the input arguments, but inside the task we can give the arguments like input and outputs. So arguments is nothing but we can passing some input values for the task and functions. So I will show you the what is arguments in the upcoming classes. So this is the difference between the task and function we have in SystemVerilog. So I'm just going to write some task and function example, then only you can easily understand. So I'm going to use only task today. Already 752. Task example. Here I'm going to use logic 3 down to 0 A. So I've created task here. So initial begin. I'm using initial begin. I'm going to simulate initial begin. Initial begin. So here I will create one task name is T1 as demo1. Demo is my task name. End task. Okay, you can see here I get one task. This is a task syntax. Task name. You can also pass the arguments here over here. So we'll see the upcoming days in the arguments passing. End task. This is my syntax of my task. A equal to 5. I'm just assigning my variable signal A equal to 5, and then I display the value of A. Value of A equal to, I want to see in my decimal output. So A. So here in the initial begin, it will after some time, after this in the initial begin I can call the task. Okay, so after 10 nanoseconds I am calling the task. How we can call the task is just write the task name and then close and open and close bracket. This is how we can call the task. You can see here I am just calling the task here. This is how we can task. So task is created here. Okay, but I am calling the task inside my simulation, inside my initial begin. Okay, initial begin is nothing but in simulation time. So I just run this. So I created the task. I created the task outside of initial begin. I am calling the task inside my simulation. Okay, so I will get an value. Why I'm getting now? Task name dollar display of value. Or else I will just A equal 5 and then I will dollar display So I just remove this file. It's working, but sometimes it will do glitches, so I don't know. So you can see here I created one task outside my initial begin. So this is my signal A. It having 4 bit. It can store up. It can work up to 4 bit. It means 0 to 5 it can perform. So and then this is one task, a demo. This is my demo is my task name. So here inside the task I am assigning value for my signal, and then I am displaying inside. I return the display statements inside my task itself. Okay, and then I'm calling the task inside my initial begin. It means inside the initial begin means it means I'm calling the task in while doing the simulation. Okay, after the 10 nanoseconds I'm calling the task. Okay, after starting the simulation, after the 10 nanoseconds I'm calling my task. How we can call means just type the task name and then open and close bracket and then semicolon. This is the method of calling the task. So if I run this, you can see here value equal to 5. So I didn't return any value inside my initial begin, but I returned the value inside my task, and then I displayed my value in the task itself. I'm just calling the task in my simulation. So you can see the output of value equal to a equal to 5. So and then if I use repeat is one function, one keyword, repeat 5 times, begin, end. So you can see here this is a repeat block. So it will repeat up to 5 times this block, this begin end. It will repeat up to 5 times of this block. So inside the block I'm calling the task. Okay, so how it will do means it will call the task 5 times. Why? Because of I am using the repeat block. I'm here, this 5 is refers to the how many times it will repeat. Okay, so this is how repeat keyword it works. So let's see that. So you can see here it will showing output like a value a equal to 5, a equal to 5, a equal to 5 up to 5 times. Why? Because of I am returning I'm calling this task inside my repeat loop up to 5 times. So same like if I change into function, I'm changing the function. So this is the syntax of function name. You can write the logic inside the function. And the main thing is function is a synthesizable, so we can use in this design code. But you can't use the design. You can't use task in your design code. It is a non-synthesizable. We can use only the simulation purpose task. So you can see here value of a equal to 5. So this is how task and function it works. So and then there are a lot of content in the task and function. We can also pass the arguments. Okay, for example input B. So here I'm assigning the data type is logic. So here B, A plus B. Okay, so I am calling while calling the function means I am passing my arguments. So this is called as arguments. So I can give the arguments, or I can pass the argument while calling the task and functions. Here I am calling the task and function, so I can pass the arguments. So I will show you. So why I am getting 6 means, so do you guys understand why I am getting 6? Why means, so this is my function argument. Okay, function argument, input argument. So here I can create the input signal for this function block. Okay, here I can, by inside the arguments I can create the input and output signals of my function, oh sorry, uh, function we can also we can only create the input signal. Okay, task we can create the input and output signal inside the arguments. Inside the arguments we can create the input signals, and then this is called as arguments. So we can pass the value for the argument. So you can see here I'm calling the function, but I passing one value for this b. So this is a one b signal for this function block. So I'm going to use this b signal inside my function block. I'm passing value for the b signal 1. So while calling the function means I can pass the arguments. This is known as argument passing for function and the task. Okay, so that this one value will go to here, and then will given to so b having the 1. So here also b having the 1. 5 plus 1 6. So that's why I'm getting the output as a 6. Okay, this is how we can use the function and task in the system Verilog. So while I will see in the upcoming days argument passing timing regions. Okay, so I think this is for today. If you guys have any doubts, you can ask now. So attendance link and I sessions, TNUH, very thank you for response. I sessions, and then doubt example for scalar n vectors. So this is a vector. So 3 down to 0 is in vectors. We can increase the sound up to the. So your logic is a user defined vector. It means we can do as much we want. 2 down to 0 means 200 down to 0. It means it will start from 0. It will count up to 200. So do you guys any doubt? You can ask now. Do you guys any doubt? You can ask now from this today. Tomorrow we'll see the remaining class groups concept. It is very big topic also. So I think this is for today. If you guys any doubt, you can ask now. Okay, thank you guys. We'll see tomorrow. Thank you for your response. Thank you for your watching this masterclass. So we'll see tomorrow with the OOPS concept and also timing regions. So please try to write some task and function. It is very simple only. So thank you guys. Thank you for listening. We'll see tomorrow.